What did it used to be? For amortization, what was the formula for P of t?
QV n plus 1 minus t.
QV to the n plus 1 minus t. So look at this. The v to the exponent is the same. Look, n plus 1 minus t, n plus 1 minus t. The difference is that this was the entire payment, the level payment, Q. Here, it's not the level payment. The level payment here would be FR, which is the coupon, which is equal to CG. This is the level payment. So the difference between this and this is that these P of T's have to add up to the whole loan, whereas this CG minus CJ is only the amount of the premium that you are amortizing, not the whole price. Follow me? That's a difference. So this is a difference. Somebody who doesn't realize that is going to write CG v to the n plus 1 minus t, because the equivalent statement to this one would be the payment. What is the payment? It's the coupon payment, which is CG. Wrong answer. Why? Because we are not amortizing the whole loan. We are amortizing the difference between the price and redemption. Get it? Okay. So here, there's one more formula on the right side. I'll just try to fit it in here. I of t plus P of t is equal to CG or FR, which is the coupon. And before we had I of t plus P of t equals R of t, which used to be Q. Everybody okay? Kind of getting a sense or no? I want to do an actual bond amortization so you can see. So the formula that should go on your cheat sheet is this one. You're going to use it all the time to cut to the chase. And everything else is just intuition. You know this already, right? The interest and the principal adds up to the payment. How much is the payment? The payment is the coupon. Okay. So, let's see. This was 6A. I was trying to see what else. Oh, there's a correction on this page. It's here on page 6. CG minus J V to the V to the n plus 1 minus t. P of t is equal to C, G minus J, V to the n plus 1 minus t. That's what I'm trying to say. Let's see what else. I think we're good. So last line on this page. P of t, which is the principal payment. This is very different for you. Something you haven't seen before maybe. Principal payment has the same sign as the difference G minus J. Now if you recall from the last lecture that we did, P minus C is either positive or negative. When P minus C is positive, it's called a premium bond. So when P minus C is positive, G minus J is positive, and P of T are positive. When P minus C is negative, G minus J is negative, and so are the P of T, negative. Imagine your principal payment is negative. That means that the coupon doesn't even cover the interest in the amortization schedule. So because the coupon doesn't even cover the interest, when you get to P of T, it's negative. So what I'm trying to say is this: the coupon minus the interest is equal to P of T, which is a negative number. So your OLB, you're going to see me do it on the amortization in a minute, your OLBs are going up in the case of a discount bond. Imagine that. Because the P of T is negative, so when you do OLB T minus 1 minus P of T is negative. So it makes the next OLB go up. That's only in the case of a discount bond. Let's, without further ado, let's go and do that, okay? It's not in your notes, so we'll make a amortization. Does anybody have a class after this? Everybody's free? Okay, I have 10 minutes. I have plenty of time to make an amortization schedule, okay? Because this will just solidify the deal. What am I saying? I have a class after this. But they can wait. Okay, let's go. Example. A $100 5-year bond with semi-annual coupons is redeemable at par. The annual effective yield is 7%. And the coupons are at 5% compounded semi-annually. Find the price, which is OLB 0. Is it premium or discount? And create amortization schedule. So, timeline. Five-year with semi-annual coupons, so there are 10 coupons. $100 bond, so F equals $100. C equals $100 because it's a par bond. I need to find FR. So first thing is R. So alpha 2 over 2 is equal to, coupons are at 5%, so 0.05 divided by 2, which is 0.025. That's R. F is equal to 100, so FR is equal to 100 times 0.025, which is 2.5. So the coupon is 2.5 throughout. I have to play with J because it's telling me that the annual effective yield is 7%. Annual though. So I have to find J. 1 plus J squared is equal to 1 plus I. So 1 plus J squared equals 1.07, and 1 plus J is equal to 1.07 to the 1/2, and J is equal to 0.03441. What's G? What happened? Melissa?
No, I just, hold on.
Talk to me. I'm holding. I'm holding.
It's just the rate. I thought, don't you want it to be compounded like semi-annually as well? So are you looking for J2 over 2?
No, because this time they gave me the annual effective interest rate. They're not giving me the nominal rate compounded semi-annually. It's because they're trying to be tricky, because it's just a formula to plug in and they're trying to trick. Okay? So this time they gave you annual effective interest rate. So 1 plus j square equals 1 plus I, solve for j. It's not nominal compounded semi-annually this time. They're not giving you j2 over 2. They're giving you I. Okay. So, I'm sorry, what was I asking you before? Find me the price. Can you find me the price? Oh, no, I know what I was asking you. What is G?
F R over C.
Do I have to worry about all that? Remember, we have something, FR equals CG equals GJ, right? F equals C in this question. How do I know? They told me it was a par bond. Par bond means C equals F, right? So if this and this is the same, then R is equal to G. Agree? How much is R? 0.025. So G is 0.025 also. Find me the price of this bond quickly so I can start my amortization. So G is 0.025 and J is 0.03441. Right? Is it a premium or a discount bond? Engage with me, people. Premium? How do you know? And why?
If it was discount, you said it would be negative, right?
So look what's happening. Look. P minus C less than 0 is equal to G minus J less than 0. Is that the case? This would be discount then. Is this the case for you or not? G minus J is negative. G is less than J, right? Therefore, it's a discount bond. So P minus C is going to be negative. Are you with me? I'm just looking at G and J. If G is greater than J, which is not the case here, it would have been premium. G is the modified coupon rate and J is the yield rate. That's not the case here. The modified coupon rate is smaller than the yield rate. That means that the coupons will not even pay enough to cover the interest. They're going to give you a coupon, but the interest that you were expecting at the yield rate, they're not giving you. They're shorting you. They're giving you less money than the interest every coupon period. So G is less than J, so it's a discount bond. What is the price of this bond? How do we find price? We have so many different formulas to find price, right? One is FR A angle N plus CVJ to the N. I could use that, or I could use price equals, what's the premium discount formula? C G minus J, A angle NJ plus C. Why don't I use that one right now? What is C? How much is C, guys?
100.
100. What is G minus J? Let's plug in. 0.025 minus 0.03441. A angle what? 5 years, twice a year, right? So there are 10 coupons. 10 at interest rate 0.03441 plus C, 100. So what do we get? Clean this up for me and tell me a price.